In this lesson, we're going to find the next terms in a geometric sequence. So let's take a look at the difference between arithmetic and geometric sequences. So when we were looking at the arithmetic and geometric sequences, first of all, they both have different functions that generate the sequence. And what we had noticed about the arithmetic sequences is that arithmetic sequences go from one term to the next by always adding or subtracting the same value. Where for the geometric sequences go from one term to the next by always multiplying or dividing. So that's the difference between the two. One, you're adding or subtracting, and then the other geometric, we're multiplying or dividing. All right, so let's go ahead and take a look at the geometric sequences. Remember, we just got done saying that a geometric sequence goes from one term to the next by always multiplying or dividing. So we'll say multiplying, let's just abbreviate that, or dividing the same value. The ratio between the terms is called the common ratio, which represents the constant multiplier in the sequence. All right, so let's take a look at this here. So we've got these terms that we're going to fill in this table and then we'll put it on the graph. What we have here is this is our first term, our second term, our third term, our fourth term, and our fifth term. And so we're just going to take these then and put them into our table. So first term, second term, third term, fourth term, fifth term. And the first term is 1/2. The second term is 1. The third term is 2. The fourth term is 4. And the fifth term is 8. Now, let's go ahead and plot these on the graph. I'm going to plot 1, 1/2. I'm going to plot 2 going up 1, 3 going up 2. Let's walk over 4, go up 4, and then walk over 5, go up 8. All right. So notice that our line is, it is a curve. It's not linear. We've got a curved line. So unlike the arithmetic sequences that are linear, these geometric sequences are not linear. Now, when we talk about the common ratio, we're talking about then what we're doing to go from one term to the next term. And in this case, it appears that we're multiplying by 2 to get to the next terms. So our common ratio here is 2. All right, so let's go ahead and take a look at how we find the common ratio. Now, the ones we're looking at here are a little bit more obvious than some of them that we're going to get. So if I look at this, notice how I'm going from 2 to 4 to 8 to 16 to 32. So it appears that we are multiplying everything by 2. So that means that the common ratio is 2. Now, I do want to point out that another way to find the common ratio is to take the next term and divide it by the previous term. And so we're going to end up doing that when they're not as easy to find, because these, we can clearly see that I'm going and I'm multiplying by 2. But when we end up multiplying by a decimal, well, then it's not as clear. So another way to find that would be to take the 16 or any two consecutive numbers and divide it by the number before it. And notice how we get 2. Well, if I took 8 divided by 4, I get 2 as well. So our common ratio here is 2. All right, for question number 2, I'd like for you to pause the video and see if you can find the common ratio. All right, so hopefully you noticed that we are multiplying by 3, so the common ratio is 3. Now, if you were having a hard time finding it, again, you can take the term and then divide it by the previous term. So 45 divided by 15, notice you get 3. Or 15 divided by 5, you get 3. All right, so let's take a look at question number 3 and see if you can find the pattern. And notice when you're going from one term to the next that you're dividing by 2. Now, when we express the common ratio though. We're going to express it as a multiplication. And so you have to think about, well, how could we multiply by something but then be dividing? And remember, we've talked about that if you were to multiply something by 1/2, it would be the same thing as dividing by 2. So right here, we would say, well, we're multiplying by the 1/2. Our common ratio is 1/2. Now, we also said that you're taking your term, let's take the 25, and divide it by 50, and notice that we could either divide it, if you do it in your calculator, you get 0.5, or you could simplify that down to 1/2. If I did the same thing with 50 and put that all over 100, notice that our common ratio is 1/2, because multiplying something by 1/2 is the same thing as dividing by 2. All right, so question number 4. Now notice question number 4, the same thing. What's happening is we are dividing, and we're dividing here by 3. But again, we're not going to write it as a division. Let's say that we weren't sure what the fraction equivalent was. Well, we could let's just take some easy ones. Let's take 1 and make it the ratio of this with the previous term. And notice we have 1/3. I could take this term and divide it by the previous term. 3 divided by 9 is equal to 1/3 as well. And also, taking a third of something is the same thing as dividing by 3. So our common ratio here is 1/3. All right, question number 5. Take a look and see if you can see the pattern. And now these are decimals, but maybe you can notice it does appear that we are dividing by 2 here. And remember, we had just said that dividing by 2 is the same thing then as multiplying by 1/2. So our common ratio here is 1/2. All right, so question number 6, let's see. I'm trying to find a pattern where I'm going from 4 to 6 to 9 to 13.5 to 20.25. Well, this one's difficult because I can't think of a number, an easy number, a whole number that I can multiply by to get from 4 to 6 and then from 6 to 9 and so forth. So here's what would be really important for us to take then and make that ratio. I'm going to take my term here and divide it by the previous term, and that's what's going to help us then get our common ratio. So if I take 9 divided by 6, I'm going to find that I have 1.5. And if I did the same thing with 6 divided by 4, I'm going to see that I get 1.5. So our common ratio, and if you want to just check it, if you took 4 times 1.5, well, you get 6. And 6 times 1.5, you get 9, and so forth. So our common ratio here then is 1.5 because you're multiplying by 1.5 each time. All right, because this video is going to end up getting to be too long, we're going to skip number 7, and then we'll go straight on to number 8. All right, question number 8. I just want to point out that sometimes you'll see your information or your sequence in a table. And so the same idea, you're looking to find the pattern, and notice that to go from 200 to 80 to 32 is not easy to find. So the easiest way to find that common ratio is to find and take, I'm going to take 80 and I'm just going to divide it by the previous term. I could have taken 32 divided by 80. That would have been fine too. So 80 divided by 200. And when I do that, I get then 0.4. So our common ratio is 0.4. And again, if you multiply 200 times 0.4 and then took 80 times 0.4, you're going to find that it will complete the sequence. All right, question number 9. Notice that you've got these points in the sequence that have been graphed. We've got 124, 236, and so forth. And so one of the easier things to do would just be to make a little XY table. And so 124, you have 236, let's just then 354, and then 4 81. And again, now it's not easy to find how I'm going from 2.4 to 30, I'm sorry, 24 to 36, but what we could do then is we could take one of the terms and divide it by the previous term. So let's try that. We'll take 36 divided by 24, and when you take 36 divided by 24, you get 1.5. And so every time you have 24 times 1.5 is 36, 36 times 1.5 is 84, and so forth. So the common ratio that you have here is 1.5. All right, example number 2, how do I find terms in the sequence? Well, first of all, let's identify if our sequence here is arithmetic or geometric. Remember that we said arithmetic goes up or down by addition and subtraction, and geometric goes up or down by multiplication or division. Notice here that we are going up by adding 2. So we know that this is going to be an arithmetic sequence. Now, to find the common difference, it's common difference for the arithmetic, and it's the common ratio for the geometric. Well, our common difference is 2, because we're adding 2. Now, if I have to list the first term in the sequence, the first term is the first term there, which is 4. And then the next term would be identifying the term that comes after this 10. So this is first, second, third, fourth. I guess that would be the 5th term. And so we're going to add 2, and you get 12. Now, to find the 7th term, we just have to bring it out 2 more places. This is the 6th and the 7th. So if I added 2, I'd have 14. Add 2 again, I'm going to then have 16. All right, question number 2, let's take a look. It appears that we have 1/5 to 1 to 5 to 25. Well, it looks like we're multiplying by 5. Since we're multiplying, that is going to be geometric. And because we're multiplying by 5, our common ratio is 5. And then that first term is the 1/5. And then we could extend this out. So if I took 25 and I multiplied that by 5 to get the next term, I'd have 125. Well, then to go out to the 7th term, I'm just going to multiply by 5 2 more times, and you'll get 3,125 when you extend that out. All right, so we're going to skip over number 3 and number 4. The recorded lesson's getting to be too long, and it won't let me post it if it's beyond a certain number of minutes. So we'll skip those and then go on to example number 3. All right, so how do I find the terms in a sequence? So we're going to find our missing terms. So the first thing you need to do is to find the common ratio. And so looking at this is a fairly easy one. To go from 2 to 6, I know that I'm multiplying by 3, and then 54 times 3 is also 162. So we're just then continuing the pattern. I would take 6 times 3, and we would then get 18. And then I would need to take 162 then as well and multiply that by 3, and I would get 486 to fill in my missing term. For question number 2, notice we're going from 32 to 16. And so let's just find the common ratio. Let's take 16 divided by 32. So I took the term divided by the previous term, 16 divided by 32, and we get 0.5. So it looks like we're dividing by 2 or multiplying by 0.5. So 128 times 0.5, I'd have 64. And then 16 divided by 2 or times 0.5 is then 8. So then this lesson, we took a look at how to identify geometric sequences to find a common ratio and then the missing terms in that sequence.